Welcome to another video. In today's video we are going to solve minimum operations to write the letter Y on a grid problem from the Leetcode. In this problem they will give a n into n grid where n value is odd. There will be n rows and n columns, and we need to determine what are the minimum number of operations that we need to perform in order to write a letter Y inside that grid. So writing the letter Y means we have to change the values which are present inside the grid to a certain values in order to get a shape Y inside that grid. I'm going to explain this with a diagram so that this question statement becomes clear. Let's consider one simple example where n is 5. That means there are 5 rows and 5 columns, and we should write a Y inside this rectangle. So if we consider all these boxes which are represented by a red dot, and if we write a certain value, which is all these boxes should have equal value. So if we join all these boxes, it represents a Y. So there are only 3 values which can be written inside that grid according to the problem statement. Either we can choose 0 or 1 or 2. Only these 3 values are present. So what we can do is we can choose a Y value that is 0, or we can choose a Y value as 1, or either we can choose Y value as 2. So if we choose Y value as 0, then the remaining values, either it should not be equal to 0. So this Y should differ from the remaining values, even though remaining values are equal. So let's say these are the remaining values. So all the remaining boxes which does not belong to Y will have a different value other than Y, but they will be equal to each other. So all those certain remaining values are represented in green color. So if we choose Y as 0, then remaining values, it can be 1 or 2. So if we choose Y as 1, then the remaining values can be either 0 or 2, because Y is 1. If we choose Y as 2, then remaining values can be either 0 or 1. So what we are going to do in order to solve this problem is we are going to traverse through the grid in order to identify all the Y points, and then we will check whether we need to modify the values which are present at Y coordinates. If that is the case, then we will increment the operations. Once we are done with all the Y coordinates, then once again we are going to go through all the points in the grid in order to check what can be the remaining value. So we will choose these combinations: Y as 0, we choose Y as 0, R as 1, and then we will choose Y as 1 and remaining as 2, and then we will choose Y as 1 remaining as 0, and then we will choose Y as Y with a value of even with a 0 we will choose 2. Then with the Y1 what we are going to choose is R equal to 2. I am writing these values from these combinations. Then we choose Y as 2, R as 0, and then we choose Y as 2, and R value will be 1. So for all these combinations, what we are going to do is we are going to iterate through the grid boxes, and we will check whether we need to modify a value which is present in that box. If that is the case, then we will increment the count of operations, and finally once we get all these counts, we will return the minimum operations. So I hope you understood this method. Let's write the code for the same thing so that this explanation becomes even easier. Implement the same solution that we have discussed before. So what we are going to do is, first we will create a set which will have all the points which belong to Y. So I'm going to call that set as Y points, and let's create a separate function in order to get these counts. Int get operations count. We'll create this function. What this function will take an argument as Y value and remaining value, and it will also get the grid for reference. So we are going to pass grid as a reference, and I'm going to write how we are going to get number of operations for a particular combination that we are considering. So I'm going to initialize operations variable to 0, and after this what I'm going to do is I'm going to create variables named total rows. Total rows will be equal to grid.size, and total columns will be equal to grid of 0.size. We can optimize this, but since it is easier to follow where we do solve some grid traversal problems, I'm going to follow a similar approach. Then after this, I'm going to create two more variables named center row, because we need this in order to identify the middle point of y, where all three branches of the y join at a point. So that is center row and center column. So center row will be total rows divided by 2, and our center column will be equal to total columns divided by 2. And now I am going to take one more variable named current row and current, which represents current row and current column. And what I'm going to do is I'm going to start at the top left corner of the grid, and I'm going to travel to the middle of the grid in a diagonal fashion. So let's start going through the grid like that. While r is less than or equal to center row, and column is less than or equal to center column, what we are going to do is we will check if grid of row comma column, since it belongs to a y coordinate, if it is not equal to y value, then we should increment the operations. And after that, what I'm going to do is I'm going to add this point to y points. So y points dot insert. So we should insert row and column, and after this, in order to travel diagonally, I'm going to increment the rows and increment the column. So now I got one branch of the y, and now I am at the middle. So once again I will start with the top right corner of the grid. So r will be equal to 0, and column will be equal to total columns minus 1. So this position represents the top right corner of the grid. So from that right corner I'm going to travel to the middle of the grid. So what I'm going to do is, while r is less than the center row and c is greater than center column, what I'm going to do is first I will check. So this condition will be same. If, since this point belongs to a y, then if it is not equal to the y that we are expecting, then I am going to increment the count, and after that I am going to add this particular point to my y point set. And after that, to traverse diagonally, what I am going to do is I have to increment the r and decrement the column. So now we are done with the two branches of the y, starting from top left corner and top right corner. So now we have to travel from the middle point of the grid to end of the grid. So for that, what I'm going to do is r will be equal to center row, r will be equal to center row plus 1, and column will be equal to center column. So while r is less than total rows and column is less than total columns, what I'm going to do is I will check, since it belongs to a y value, I'm going to write this check again. And after that, in order to travel just a box below that middle point, what I'm going to do is I'm just going to increment the r, column remains same in this case. So now we have traversed through all the y points and we have counted the operations that are needed to form a y with the given value y. So now we will go through the remaining for all the grids. For int r equal to 0, r less than total rows, r plus plus, and after this int column equal to 0, column less than total columns, column plus plus. So now we will travel through the grid once again and we will check if grid of r comma c is not equal to remaining value. So we are expecting a y value at y coordinates and a remaining value at a remaining coordinates. If that is not equal to remaining, and if this point, that is the point that we are considering, does not belong to a y coordinate, so y points dot find of row comma column equal to y points dot end. If this is the case, then that means that particular the box inside the grid that we are considering does not belong to a y point, but it has a different value than what we are expecting. So at that case we have to increment the operations. So that's all we have to do, and finally we should return the operations. So we have to do this for all possible combinations considering 0, 1 and 2 values. So what I'm going to do is, initially I'm going to declare a variable named minimum operations and I'm going to initialize it to a very high value. Since n is given as maximum limit as 49, what I'm going to declare it here as, ideally we should give a very high value to consider it as infinity. So minimum operations I'm going to initialize with 50 into 50 value, because I know that maximum value of n is 49. So after that, what I'm going to do is int current operations will be equal to, I'm going to call this function get operations count with a y value of 0 and a remaining value of 1, and I'm going to pass the grid, and I'm going to update the minimum operations if it is if current ops is lesser than minimum operations. Minimum operations will be equal to, I will check whether current operations is less than minimum operations. If this is true, then I am going to assign current operations value, otherwise I am going to keep the same minimum operations value, minimum ops. So I'm going to do this for each and every combinations. So I'm going to call this again and again, current operations with a y value of, we have considered y value 0 and the remaining value as 1. We have to change this to 2. Now we have considered 2 combinations, so we have to do this for the remaining combination of values that we have discussed in the explanation. So I think it should be get operations count with a small p. So now we will change the y value to 1 and we will choose remaining value as 0, and after this, so we will keep y value as 1, remaining value as 2. And other 2 combinations we should consider is y value as 2 and the remaining value as 0. And after that what we are supposed to do here is, I think this is the last combination, so that is y value as 2 and the remaining value as 1. And finally we are going to return the minops. So this is the brute force way of solving this problem. Let's submit the solution and check whether we have done any mistakes in implementing any of these functions. Let's see if it passes the initial test cases. Okay, we have some typos here. Okay, center column. Let's run it again and check if it finds any other typos or okay. As you can see here, this solution is passing the initial test cases. Let's submit the solution and check whether it passes all the test cases or not. Yes, as you can see here, this solution is passing all the test cases. If you are interested in learning more about other data structures and algorithm related problems, please check out other videos from my channel. Thanks for watching this video.